Y'all, this is the third time that I've recorded this video. The first two times the volume didn't work. I just did a test and my volume was fine. So let's hope. I'm going to try to, I don't want to skimp on this, but I'm not going to be telling a lot of stories. All right, completing the square. Let's look at these two equations. Sarah is saying that her polynomial is a perfect square trinomial, which it is, because you have to look at your C term, see if that is a perfect square. It is. Your term in front of your X, your A term, that is a perfect square. It's a 1. And if you do square root of 4, you get 2. Square root of 1 is 1. 2 times 1 is 2. And then 2 times 2 is 4, which is your B value. So yes, it is a perfect square trinomial. It would be x plus 2 squared equals 0. Now we're going to use the square root method to solve it. So square root of both sides, you get x plus 2 equals 0 because square root of 0 is 0. And then subtract 2 on both sides and you get x equals negative 2. That's the answer. That's it. Okay. So next one says John rewrote his equation as x squared plus 4x minus 2 equals 0 to try to see if he could factor it. And then he's like, yeah, I can't factor it. There's no way to factor that with factors and sum. Doesn't work. And can't do square root method either because it's not a binomial squared. It's not like x squared equals 25. And then this one has a B term. So we can't do square root method. So I agree. Can't do factoring or square root method. So let's look at the two equations. Next one says to compare those two equations, figure out how John could transform his equation into a perfect square trinomial while keeping the equation balanced. Okay, that's key. Keep that equation balanced. Some of you might be like, it might already be in your head because we had a test question over this. I can't remember if it was the original test or the retest, but that question said, what term could you put in here to make this a perfect square trinomial? So think about John's. What could we put in that equation to make it a perfect square trinomial? If you discovered that we could just rewrite this as x squared plus 4x plus 4, because that's what Sarah's is, and hers was a perfect square trinomial, all we had to do is add that 4 in there. But remember, what you do to one side, you have to do to the other. Okay? Keeping it balanced. That's why I underlined balance. Okay, so completing the square. That's a method of solving quadratic equations by first changing one side of the equation into a perfect square trinomial. All right, next it says trinomial. Can't do two things at once. Trinomial. Practice completing the square of these polynomials in the form x squared plus bx plus, we need to find out what that value is that is going to make this perfect square trinomial. And this is a formula. This is why I like completing the square because it's a super easy formula. So you take that value of b, divide it by 2, and then square it. So let's look at number 1. It'll make sense. All you have to do, take your value b, which in this case is 10. Do 10 divided by 2, that equals 5. And then 5 squared is 25. There you go. That's it. If you all want to pause me so that you can see if you did these right. The next one, half of negative 18 is negative 9. Negative 9 times negative 9 is positive 81. And then this last one is 49. Half of 14 is 7. 7 squared is 49. That's it. That's all I like completing the square. See, it's pretty easy. As long as you can remember those 2 steps, makes it pretty easy. Okay, so solving completing the square, you have to isolate the variable terms. Usually it's a x. Isolate those to one side of the equation. So just make sure all of your variables are on the same side. Find the missing c value to create a perfect square trinomial and add that c to both sides of the equation. That's huge. add it to both sides of the equation. And then factor and write as a binomial squared. Binomial squared is just like that parentheses of x plus 2 squared. That's what that is. So write it as a binomial squared and then solve using the square root method. So we're going to do this over here on the left. So that original equation, you can't factor it and use the square root method. So that's where we're going to complete the square. So if you looked, what they did is terrible plus sign. They added 4 to both sides so that we can make room for our new value of c. And so half of 6 is, 6 divided by 2 equals 3. 3 squared is 9. So 9 goes right here. And then 9 goes to the other side. So now we've made a perfect square trinomial. So this would just be x plus 3 squared equals 13. So now we're just going to solve using the square root method. So square root both sides. We're left with x plus 3 equals, and you have to think before you go any further, can I simplify this down with that simplifying radicals? We can't simplify 13 down because the only factors are 13 and 1. So there's no simplifying. So this would just be square root of 13 and subtract 3 on both sides so we can solve for x. So your answer is x equals -3, and we have to write that plus or minus because it could either be a positive or a negative number to get to 13. And that's it. All right, so we're going to do the same thing with all these. So just go ahead. You can't factor any of these, so we have to complete the square for all of them. So we're going to rewrite this as x squared plus 2x plus, leave my little line there, equals 9 plus, put my line there again. That kind of reminds me I need to do it on both sides. So half of 2 is 1. 1 squared is just 1. So your value is just 1 on both sides. And then square root of 1 is 1. So this would just be x plus 1 squared equals 9 plus 1 is 10. So we're going to now square root method because we're following those steps. So we have x plus 1 equals, let me think about 10. Can I simplify that down? Factors are just 10 and 1 and 5 and 2, and none of those are perfect squares. So it's just going to be square root of 10 and then subtract 1 on both sides. X equals -1 plus or minus square root of 10. Okay, guys, if you all want to pause me and try to do number 5 on your own, I think that would be great. I'll give you a second. All right, I'm going to get started on this. So first thing, I'm going to subtract 4 from both sides. Oops. So that's a terrible 4. Both of them are terrible. So that I can make way for my new value. Oops, it's not plus 8. So minus 8x plus, whatever my number is, equals -4 plus that number. Okay, half of -8 is -4. -4 times -4 is positive 16. So 16 on both sides. So my binomial squared, this is x minus 4. Just remember, -4 times -4 is positive 16. -4 plus -4 is -8. So always remember to do your, check your signs. -4 plus 16 is 12. So let's go ahead, square root both sides. X minus 4 equals, before I write that, let me think if there are any factors that could help me simplify this. So 12 and 1, 6 and 2, and then there's 4 and 3. So 4 is a perfect square, so we can simplify it. So remember, that's the same thing as square root of 4 times square root of 3. Square root of 4 is 2, so it'll just be 2 square root of 3. That would be the simplified version of that. So x minus 4 equals 2 square root of 3. So my new answer, try to add 4 to both sides, is x equals 4 plus or minus 2 square root of 3. We can't combine those because that 2 is like hooked up to that square root of 3. So we can't combine those two terms. So you just leave it as 4 plus or minus. Can't do anything else with it. Yeah, and if you all are wanting to do any of these on your own and just check your answer, just put me on pause. I won't be offended. All right, so first thing I need to do is get rid of my c that I have now by subtracting 10 from both sides. Now I've got x squared plus 4x plus whatever this is equals 12 minus 10 is 2. So 2 plus whatever my new value is. All right, x, or half of 4 is 2, and then 2 squared is 4. So 4 on both sides. Binomial squared, x plus 2 squared equals 2 plus 4 is 6. Let's do square root method. So x plus 2 equals, can 6 be brought down any? No, just 6 and 1 and 3 and 2. None of those are perfect squares. So x plus 2 equals square root of 6. Subtract 2 from both sides. So your answer is x equals negative 2 and then plus or minus square root of 6. Okay, number 7. First thing, I'm going to add 4 to both sides. I'm going to be really mad if this volume doesn't work again. Whoops. I don't want to do it. Okay, so now I've got x squared minus 12x plus whatever number is going to go right there equals 8 plus 4 is 12 plus my new term. Negative 12, half of that is negative 6. Negative 6 times negative 6, positive 36, so 36 on both sides. So this binomial is x minus 6 because we've got this minus right here. X minus 6 squared equals 12 plus 36 is 48. So let's square root both sides. Hopefully you guys tried these on your own and you are going to get the correct answer. All right, so 48, let's think if that can be simplified. Lots of factors of 48. 48 and 1, 24 and 2. But the one that has the biggest perfect square in its set of factors is 16 and 3. So again, that's the same thing as square root of 16 times square root of 3. Square root of 16 is 4, so it'd be 4 square root of 3. That's a simplified version. So x minus 6 equals 4 square root of 3. So to solve, finish it out, add 6 to both sides. And our answer is x equals 6 plus or minus 4 square root of 3. There we go. Hopefully you guys got all those right. And you are like, I got this, I got this. I hope. No. All right, so next up, completing the square can be used to convert quadratic functions from standard form into vertex form. So what vertex form tells us? It tells us, first of all, if the graph is going right side up or if it's going upside down. Also, it tells us where that point on that parabola, where the absolute lowest point is or the absolute highest point is. So in a vertex, you've got like absolute value on a graph. That vertex is where those two like rays meet. Same thing with a parabola. It has a minimum or a maximum. And that's what we're going to look at with vertex form. So vertex form is y equals a times x minus k squared plus h. Don't shoot the messenger. I don't like it either. There's a lot of letters. This is hard to remember. It just is what it is. So, but this is the vertex form. Once we kind of solve, you'll see what all of those numbers kind of mean. All right. So let's look at this equation, y equals x squared minus 8x plus 11. So we're going to use completing the square because it's not factorable and we can't use the square root method. So again, same as before, I'm going to subtract 11 from both sides. So now I have y minus 11. And again, I'm going to have to add a number to both sides because we're completing the square. So I'm going to leave my little line or blank equals x squared minus 8x plus, and here's my blank. All right, so negative 8, half of that is negative 4. Negative 4 squared is 16. We had a problem like this earlier, I think. So I'm going to combine on the left-hand side. Y negative 11 plus 16 is plus 5 equals, and we can just do our binomial squared. Go ahead and do that. That's going to be x minus, what is the square root of 16? 4. Minus 4 squared. And again, make sure you have that sign right. I'm solving for y, so I'm going to subtract 5 from both sides because we're putting it into vertex form. So if you need to look back at that formula to kind of get it in that same kind of condition, that's super helpful. So y equals x minus 4 squared minus 5. So now we're in vertex form, which is y equals a, that's a number on the outside of your binomial squared. We don't see it, but in this case, there's a 1. X minus k, k is one of our numbers, and then plus h. H is another one of our numbers. It's kind of like in slope-intercept form. The m and the b, those stand for numbers. Those have a reason, okay? So the vertex of this function. So the vertex, that's an ordered pair. And again, it's where it's either the lowest or the highest point. So your x value is that number that is inside the parentheses with your x. Main thing to remember though, change the sign. Inside of the parentheses, it's negative 4. So now it's going to be positive 4. And then your h value is this number on the end. Kind of like the y-intercept is like that b on the end. We don't have to change the sign because it's not inside of parentheses. So it would be 4, negative 5. That's the vertex. That's where that parabola either is the very lowest or, again, the very highest. Does this have a minimum or a maximum? And how do we know? So this right here tells us that A tells us so much. It tells us if that parabola is going right side up, kind of making a smiley face, which means positive, or if it goes upside down frown, that's when it's a negative number. So in this case, we look at our number right here. We don't see it, but we know that's a 1, and it's a positive 1. So that means we have a minimum. Minimum. That is a smile because it is a positive number. Positive, your smile goes up. If it's negative, it goes down. If you're negative, you're frowning, it goes down. Don't you like my faces? So minimum, the A value is positive. All right. So now here is Miss Flake's like super duper scientific way of telling you if or how many x-intercepts this has. So let's look at this point. And I want to use this graph out here for an example. The point is 4, negative 5. So if I were at 4 and then go down to negative 5, there's my vertex right there. I've already determined that that is a minimum. So that is the lowest point on the graph. So that means it opens up like this. How many times does that cross the x-axis? Twice. 2. So just go ahead and think about, number one, kind of where that point is on the graph. If it was over here in quadrant 3, yep, sure would. If it was in quadrant 2, though, and you knew that was a minimum, how many x-intercepts would you have? 0. This one that's originally on here, that has 0 x-intercepts as well. Quadrant 1, if it has a minimum and it's in quadrant 1, you automatically need to know that it does not have any x-intercepts. Okay, super scientific, I know. Okay, so and use your graphing calculator if you want to check your work. Okay, this last one, Mr. Ritchie asked his class to sketch a graph of the function. Selena did it, and here it is. We need to verify, see if she is right or wrong. So our equation, y equals x squared plus 12x plus 37. Okay, so first thing I'm going to do, I'm going to subtract 37 from both sides. And now I've got y minus 37 plus a number equals x squared plus 12x plus a number. Okay, half of 12 is 6. 6 squared is 36. So that's going to be our completing the square. All right, so my binomial is x plus 6 squared equals negative 37 plus 36. That is negative 1 minus 1. So last step in solving is to add 1 to both sides. And then you're left with y equals 1. Got ahead of myself. Y equals x plus 6 squared. And then we're going to put the 1 on the end because that's what vertex form is. That number, that constant, it's on the end, just like in slope-intercept form. All right, so our vertex of this, again, your x value is the number inside of there, but we have to change the sign. So it's negative 6, and then y value, positive 1. So let's look and see. I see what she did wrong. She plotted positive 6, positive 1. She didn't change the sign. So see, a little thing like that would make it completely wrong because it's in the wrong spot. It would be over here, negative 6, positive 1. Roundabout. There we go. There it is. There's your parabola. All right, guys. I am signing off. I'm tired. Hope you guys have a good day.